Department of Education in conjunction with Saibono Discovery Center. My name is Bongani Mabuya, and we are still continuing with topics examinable in grade 12. So today we are going to talk about electric circuits. That is the topic of the day, electric circuits. And this question in grade 12, you will be asked about it, and it can carry a... So what is it that I want you to know? It is that at the end of the lesson, you should be in a position to state Ohm's law in words and also solve problems using Ohm's law formula. Furthermore, you should distinguish between series and parallel circuit. So we are going to look at series circuits and we are going to look at parallel circuits. Then you should define power and be in a position to use power formula to calculate for power or to solve circuit problems. So this is what we are going to do today. So the concept map about circuits, one thing that you need to understand is that there is a triangle relationship between the current, potential difference, and resistance. And we know that when we talk about the current, we are talking about the rate of flow of charge. So that is the current. And when we talk about potential difference, we are referring to the work done in displacing a charge from an area of high potential to an area of low potential. And when we talk about resistors, their function is to do what? To oppose the flow of current. So this is what we are talking about, that when we talk about circuits, we need to bear in mind terminal voltage. Terminal voltage, it is the potential difference across the circuit. So that total voltage across V external, V load. So all of these terms, they refer to terminal voltage, V load, terminal voltage, potential difference external. So this is what it means. So here we are referring to volts. And then later in 2022, you'll have to deal with EMF and also what we call internal resistance. So this one, it links also to V loss. And then today we are going to talk about Ohm's law that gives us an insight of the relationship between the potential difference, current, and resistance. Then we are going to talk about power, and we are going to use power formulas to solve circuit problems. I did mention to you that we will look at the two types of circuits, which is the series circuit and the parallel circuit. But we are not going to limit ourselves to that. We are also going to look at the combination, where we are having a diagram that has both series and parallel circuit combination. So let us look at the exam guideline. Let us look at the exam guideline, of which this is what I always emphasize, that the exam guideline, it is our friend. We need to refer to the exam guideline. What does it say? When we deal with electric circuits, it tells us that the first thing that you look at is Ohm's law. That is the first thing that you look at. It is Ohm's law. And Ohm's law, it tells us about this triangle relationship between the current, potential difference, and resistance. So this is what you need to bear in mind, that when we talk about the Ohm's law, we are referring to the current, we are referring to the potential difference, we are referring to resistance. So it tells us how these three concepts behave. So the exam guideline, it tells us that the first thing that you look at when we deal with circuits is that we must talk about Ohm's law. And we need to define Ohm's law the way it appears from the exam guideline. So it is very important to define it the way the exam guideline defines Ohm's law. So it says state Ohm's law in words. You'll be required to state Ohm's law in words for 2 marks. And I'm saying that for 2 marks, let's make sure that when it comes to definitions, we get all the marks. Because for definitions, it's 2 marks or nothing. So that is why I'm saying that all these terms which are stipulated in the exam guideline, let's sing them the way they appear from the exam guideline. So let's define them exactly the way they are defined from the exam guideline. So it says, the exam guideline, state Ohm's law in words. So an indication is that as well in your assessment, you will be required to state Ohm's law in words. So that is something that you need to expect, that you will be required to state Ohm's law. And it says, state Ohm's law in words as the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. At constant temperature. So this is what Ohm's law states. It tells us that the potential difference across the conductor is directly proportional. So the potential difference is directly proportional to the current. This is what the Ohm's law is telling us, that the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. So you will be asked or required to use this law. And a question might arise, maybe a question that says, which factor must be kept constant? So if you want to obey Ohm's law, temperature must always remain constant. So this is what the law is saying, that the potential difference across the conductor is directly proportional to the current in the at constant temperature. So the fixed variable is constant temperature. And where do we get that? From the law. So the law is telling us that this potential difference is directly proportional to the current in the conductor at constant temperature. So I'm merely motivating you learners to make sure that these laws, the principles, the definitions, they become our national anthem. So let's sing them the way they appear from the exam guideline. So when it comes to Ohm's law, first thing that you need to think of when we deal with electric circuits, it's Ohm's law. And Ohm's law, it states that the potential difference across the conductor is directly proportional to the current in the conductor at what? At constant temperature. So don't forget, at constant temperature. So this is what the exam guideline is saying. And we need to stick to the exam guideline. Then it says, determine the relationship. So Ohm's law, it tells us about the triangle relationship between current, potential difference, and resistance. So from Ohm's law, you can see that it tells us that this current is directly proportional to the potential difference. Okay? Meaning that's going to be divided by resistance at constant temperature. And also, it can be written like this: R is equals to V over I. More especially depending on the experiment that will be conducted. So, the exam guideline then says, pay specific attention to the relationship between current, potential difference, and resistance. Because one thing about circuits is that we are merely looking at the relationship between the current, potential difference, and resistance as to how do they affect each other, and also how do they impact each other. Furthermore, then it says state the difference between ohmic conductor and non-ohmic conductor and give an example of each. So this is what the exam guideline is telling you. And when we say that we are having an ohmic conductor, we are referring to conductors that obey Ohm's law. That is an ohmic conductor. And a non-ohmic conductor, it's a conductor that does not obey Ohm's law. And remember, Ohm's law, it says the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. So you find that some of the conductors, when the current is flowing in the conductor, okay, and we are saying that the current is directly proportional to the potential difference, but you find that the temperature of the conductor increases. So such conductors, they do not obey Ohm's law because they've neglected this statement that says at constant what? Temperature. So once we start to have a difference in temperature, then that conductor, it's non-ohmic because it does not obey Ohm's law. So it is important to be in a position to compare and contrast ohmic and non-ohmic. Ohmic obeys Ohm's law. And what does Ohm's law say? It tells us that the potential difference across the conductor is directly proportional to the current in the conductor. At what? At constant temperature. So an ohmic conductor, it obeys that law, Ohm's law. And a non-ohmic conductor then is the one that does not obey Ohm's law. Then the exam guideline then says using this formula of Ohm's law, you will be required to solve problems of series and parallel even combination circuits. But you'll be restricted to maximum of 4 resistors. You'll be restricted to 4 resistors. So one thing that you must expect is that you will be given a circuit diagram where you'll have to perform calculations. But you'll be restricted to maximum of 4 resistors. Let's move on. Then let's talk about power. So the exam guideline then says define power as the rate at which work is done. This is what the exam guideline is telling you. They define power as the rate at which work is done. And when we talk about the rate, we're talking about per time divided by time. So power is then expressed by this formula that says power is equal to work done divided by change in time. And we know that the units for power, they are watts. You'll be required to solve problems using these 3 fundamental questions of power. We'll look at their relationship more today. So power can be expressed by this formula is equals to VI. Power can be expressed by this formula that is equals to current squared multiplied by resistance. Power can be expressed by the formula of V squared divided by R. And then it says that you'll be required to solve problems using these equations. So the exam guideline is telling you that you will solve problems using power. And then deduce that the kilowatt per hour refers to the use of kilowatt of electricity for 1 hour. And with that information, then you should be in a position to do what? To calculate the cost of electricity. So let's talk about circuits. So components, they can be connected in series and they can be connected in parallel. So when we talk about a series circuit, we are saying that all of these components, they are connected along the conductor. So they are series circuits. And this way you can see that there's only one pathway from positive terminal to the negative terminal of the battery. So the exam guideline has stipulated that look at the relationship. So when we talk about series circuit, what's important is for us to deduce information about current, to deduce information about potential difference, to deduce information about resistance. Because we need to know the relationship between current, potential difference, and resistance in series. So one thing that you must know is that in series circuits, the current remains the same at all points. So this is what you need to remember, and it's going to help you when you perform calculations, that in series current is the same. So the current measured here is the same current measured here, is the same current measured here, is the same current measured here. So what does this mean? It means that in series current is the same. So in series, current is the same. And you can see 0.64 amperes, 0.64 amperes, 0.64 amperes, 0.64 amperes. So this tells you that in series, current is the same. And the units for current are amperes. So when you talk about the units for current, we know that they are amperes, and the symbol is A. And the device that we use to measure current, it's called ammeter. So don't be shocked in the exam when they say determine the ammeter reading. Then you're like, I was not taught of this. No, ammeter reading reads the current. So the device that we use to measure current is called an ammeter. So what's important is that in series, current is the same. In series, current is the same. Now, then let's talk about potential difference. For us to get V terminal, it means we must add V1, we must add V2 to get V terminal, V load. So what does this mean? It means that potential difference in series is divided. So the potential difference in series is divided. So for us to get terminal voltage, we must add V1 and V2 and so on. So let us compare now. We are saying that in series, current is the same. The potential difference in series is divided. And the units, we say they are volts, which is V. So the symbol is V. The device we use to measure potential difference, it is called voltmeter. Let's move on. Then let's talk about resistance. So resistance in series, the total resistance is the sum of resistance of each resistor. What does this mean, sum? So this means that in series, we add resistors. So it's R1 plus R2 plus R3 and so on. So it's very important to look at that in series, the current is the same. Potential difference is divided. We add resistance in series. So this is fundamental. So we need to remember that when we refer to the series circuit, current is the same. Potential difference is divided. We add what? Resistors. Then let's talk about parallel circuit. So when we talk about parallel circuit, how do we see a parallel circuit? So the evidence of parallel circuit is that resistors are connected in parallel. So a light bulb also is a resistor, and you can see how they are connected here. They are connected in parallel, and you find that there is more pathway of current in parallel circuits. Now, let's look at the relationship of current, potential difference, and resistance in parallel. Remember, now we do know that in series, current is the same. In series, potential difference is divided. In series, we add resistance. So now let's look at parallel. When we talk about current in parallel, a current in parallel, let's look at this current, which is 1,50. So it can flow and flow and flow and flow. When it reaches this point, some of the current will go that way, some of the current will continue to move in opposite or towards the forward direction. So what does this mean? It tells us that current along the way, it becomes what? Divided. So current in parallel is divided. So this is what I'm trying to draw your attention to. It is that current in parallel is divided. The current that flows here is the total current. The current in series is total current. And it will flow and flow and flow. When it reaches this point, some of the current will move in this direction. Some of the current will continue to move in a forward direction. So this tells us that indeed current is divided. So in parallel, current is divided. Then let's talk about voltage, potential difference in parallel circuits. Potential difference in parallel circuit is the same. So that's what's important. So this is important. Potential difference in parallel is the same. And then, so let's look at this diagram. So we are saying that the potential difference measured here from this point to this point is the same potential difference measured from this point to this point. It's 5 volts, 5 volts. Why? It is because the potential difference in parallel is the same. Let's move on. Then this is how we solve resistors in parallel. It's going to be 1 over resistors in parallel is equals to 1 over resistor 1 plus 1 over resistor 2 and so on and so on. And then at the end you must flip your answer. But if you only have 2 resistors connected in parallel, then also this formula is applicable. Resistors in parallel is equals to the product of resistors divided by the sum of resistors connected in parallel. But this formula is only applicable if you only have 2 resistors connected in parallel. Let's move on. So I have alluded to you that the combination is something that you need to expect. Since now we are going to grade 12, expect a combination circuit that has both series and parallel. So you should be in a position to distinguish series current is the same. Parallel current is divided. Series potential difference is divided. Parallel potential difference is the same. So you should be in a position to distinguish series and parallel circuit. But expect a situation where you are given a circuit diagram that has both series and parallel connection. So to warm up, I am going to give you 5 minutes to respond to this question. Now, I'm interested in your response to this question. The first thing that you need to look at is the diagram itself. You can see that this diagram, it is the combination circuit, series and parallel. You look at the resistors, how they are connected. These ones, they are connected in parallel and they're in series to this resistor. So let's look at the question. In the accompanying circuit diagram, the battery has an EMF of 9 volts and ammeter reads 0.2 amperes. So this ammeter, it reads 0.2 amperes. Calculate the current through the 5.5 ohm resistor. So we want the current that flows here. And remember, what did we say? We said that the current in parallel is divided. Okay, so it does not mean that this current is the same with this one, because these resistors, they are connected in parallel. So the current in parallel is divided. So now, let's look at the easiest way of getting this answer. For this resistor, we have the value of the resistor, which is 11 ohms, and we have the current. We can get the potential difference across 11 ohm resistor. So that's the first step. We can fight to get for the potential difference of 11 ohm resistor. And we are saying that for 11 ohm resistor, we do have the value of R, which is 11 ohm. We do have the value of current, which is 0.2 amperes. So you write the formula the way it appears from the data sheet. R is equals to V over I. So for copying this formula, you get 1 mark, provided that you are going to do what? To substitute. So R is equals to V over I. What is our resistor? It's 11 ohm equals to, we do want the potential difference across the 11 ohm resistor, divided by the current that passes through the 11 ohm resistor, which is 0.2. So you get a mark, you get a mark. So this is what we are saying. Write down the correct formula. Substitute correctly. So the power is with writing the correct formula and doing what? Correct substitution. Then transpose divided by 0.2 is going to be 11 times 0.2 is equals to V. Therefore, V will be, you take your calculator, 11 times 0.2, and then your answer will be 2.2 volts. So you only have the value of the potential difference across 11 ohm resistor V, which is equal to 2.2 volts. And then now you need to apply the knowledge of series and parallel circuits. And what did we say? We said that if resistors are connected in parallel, their potential difference is the same. I love this. I love this. If resistors are connected in parallel, their potential difference is the same. So if for 11 ohm resistor, the potential difference across the 11 ohm resistor is 2.2. As well, the potential difference across 5.5 ohm resistor is what? Is 2.2 volts. So now for 5.5 ohms, now we have two values, the value of the resistor and the value for V. We can calculate the current. So now you can say now for 5.5 ohm, we do have R, which is 5.5 ohm. Now we know the potential difference is 2.2 volts. Why? Because 5.5 ohms and 11 ohms, they are parallel to each other. So we can calculate for the current. You write the formula. Current is equals to V divided by R. What is your V? 2.2. What is your resistance? 5.5. Then you punch your calculator. And current will be 0.4 amperes. So it's 1, 2, 3, 4, 5. So you can see that the power of writing the correct formula. Write the correct formula. Substitute correct. I'm telling you, you will get all the answers. Let's move on. Let's move on. Let's move on. Let's move on. Now let's talk about power. The exam guideline has stipulated that define power as the rate at which work is done. So this is what the exam guideline is telling us, that define power as the rate at which work is done. And the symbol for power is P, and the units of power is watts. So this is the formula for power. Power is the rate, meaning divided by time, is the rate at which work is done. So your data sheet will give you these three possible formulas that you can use depending on the situation or scenario that is given in the exam. So you can calculate power using this formula. P is equals to the product of potential difference and current. Or power can be calculated by this formula of current squared multiplied by resistance. Or power is equals to terminal voltage squared divided by resistance. So depending on what you are given from your circuit diagram, you can use any of these formula. But here is a question. The question stands now. What do these formulas tell us about power relationships? So what is it that these formula tell about power relationship? Let's look at the answer. Let's start with the first formula that says power is the product of potential difference and current. So from this formula, you can see that potential difference and current, they are having a linear relationship, meaning that power depends on both current and potential difference. Provided that your power will remain constant, we are saying that the current and potential difference, they are directly proportional to each other. So the first formula then, it tells us that indeed there is a practical method of measuring power by using what? By using an ammeter and voltmeter. Meaning that for you to get the power, it depends on the both current and potential difference. And let's look closely at the relationship of this formula. It tells us that if you maintain power, you keep power constant, then potential difference is directly proportional to current. So this also tells us about Ohm's law, that yes, indeed, at constant temperature, okay, at constant temperature, the potential difference across the conductor is directly proportional to the current in the conductor. Let's move on. Now let's look at the second formula. What does it tell us? Power is expressed by this formula, which is current squared multiplied by resistance. So we are saying that if you are going to keep resistance constant, provided that your resistance becomes constant, then we are saying that power is directly proportional to the current. This is powerful. So we are saying that power is directly proportional to the current squared. So if your resistance is going to be constant, then power is directly proportional to current squared. So it's going to form this linear relationship. Let's move on. Let's move on. Let's move on. And please continue to engage with us on our WhatsApp platform, which is 082-760-2630. Let us engage with content. Now, let's move on. Here is an expression as well of power. Power is expressed by this formula, V squared divided by R. So we are saying here, if you keep resistance constant, the same thing is applicable. Power is directly proportional to potential difference squared, provided that you keep the resistance constant. So we are saying that power is directly proportional to the potential difference squared. So this is what these relationships tell us about power. So here is a question, and I'm going to give you 10 minutes to respond to this question. 10 minutes. Now, let us do corrections to this question. Merely let us do it together because this feedback is ours. The first thing that you do, understand the question. Let us read the statement carefully and comprehend it. So it says that in the following circuit diagram, the battery has an EMF of 12 volts. Two 6-ohm resistors are connected in parallel. So these two 6-ohm resistors, they are connected in parallel, one another, and in series with a 2-ohm resistor. So the statement is telling us that 6-ohm resistors, they are connected in parallel, and they are in series with the 2-ohm resistor. And we do have what? An ammeter that reads the current there. So this is what the statement is saying. And already you analyze the diagram and you extract the information that you need. So the first question says, calculate the external resistance, R external. Calculate the external resistance of the circuit for 4 marks. So you separate these two scenarios. The first situation, you start with a parallel. The second one, then you deal with series. So let's deal with the resistors in parallel. So you're going to say resistors in parallel. How many resistors do we have in parallel? They are 2. It's 6 ohm and 6 ohm. So you can use this formula that says R1, R2 divided by R1 plus R2. What is our R1? It's 6. What is our R2? Is 6 over 6 plus 6. Then what will be your answer? You punch your calculator and I think you are going to get 3 ohms. So this is the resistance in parallel. So for us to get R external, it's when we add resistors in parallel with the resistors in series. So our resistors in parallel, it's 3 plus the one in series, which is 2 ohm, according to the statement. It says it is then connected to a 2 ohm resistor in series. So then we're going to say plus the resistor in series, which is 2, meaning that external resistance is equals to 5 ohm. So this is what the question required you to do. And it was 4 marks. So 1 mark of the formula, 1 mark of the answer. 1 mark for adding and 1 mark for the final answer. So we are merely saying that recall that information of the relationship between current, potential difference, and resistance. Let's move on. Let's move on. The second question then says, determine the reading on the ammeter. I did say that. Reading on the ammeter, it means the question wants us to calculate for the current. This is what the question wants us to do, to calculate for current. So this current, you can see that it flows through series. So we are referring to the total current that flows in the circuit. So for us to get the total current, then we are going to say IT is equals to V load divided by R external. So we're told that the battery gives the circuit 12 volts divided by R external, which is 5 ohm. So what will be the total current that flows in series? It's 12 divided by 5, and I think that our answer is going to be 2,4 amperes. So this is 3 marks. 1 mark of the formula, 1 mark for substitution, 1 mark for the final answer. So this is what the question wanted us to do. Now let's move on. I'm also going to give you 10 minutes to do this calculation. 10 minutes. Now, class of 2022, let us respond to this question. A voltmeter connected across 8 ohm resistor reads 21,84. This is 21,84 volts. And analyze the diagram. Analyze the diagram. So you should be in a position to see that this is a combination circuit. And a combination circuit, how do we see it? These resistors, they are connected in parallel, and they are also in series to this 8 ohm resistor. So it's very important to analyze your diagram, because when you deal with circuits, what's important is to be in a position to analyze your diagram. So the circuit diagram should be extensively analyzed. The first question then says, calculate the current in the 8 ohm resistor. So we do have the value of R, which is 8 ohm. We do have the value of V, which is 21,84 volts. So the question says, calculate the current in the 8 ohm resistor. So you just write the equation, R is equals to V over I. So you write the equation the way it appears from the data sheet. So this is what we are saying, the way it appears from the data sheet. So what is your resistance? It's 8 ohm, equal to. What is your potential difference? It's 21,84. The question wants you to calculate for current. So we are saying that write down the formula and substitute. So you have a mark, you have a mark. So you have 2 marks out of 3 marks. Then you transpose divided by current. It's going to be multiplied by current is equal to 21,84. So you solve for current. You divide both sides by 8. They cancel each other. Therefore, current is equal to 21,84 divided by 8. And what will be your answer? 2,73 amperes. 1 mark. So make sure that even when you write your answer, put the correct units. So you become credited 3 marks if you have done something like this. Then let's move on. Number 2, calculate the equivalent resistance of resistors in parallel. In parallel. We don't want everything, but only resistors that are connected in parallel. So we want resistors connected in parallel. Then you can say RP. How many resistors are connected in parallel? So it's 1, 2. So then you can use this formula that says R1, R2 divided by R1 plus R2. What is your R1? It's 30. What is your R2? 20. Divided by 30 plus 20. So then you go to your calculator and you punch 30 times 20, 30 plus 20. And I think your answer will be 12 ohm. So this is the equivalent resistance in parallel. It is equals to 12 ohm. Then it's 2 marks. So the mark allocation is 2. So 1 mark for this and 1 mark for the answer. Then the third question then says, calculate the power dissipated by the 8 ohm resistor. Calculate the power dissipated by the 8 ohm resistor. So we can have 3 options, 1, 2, 3. The first one, you can say power is expressed by this formula. Power is equals to VI. What is the potential difference of the 8 ohm resistor? It is 21,84. And what is the current that flows to the 8 ohm resistor? So the current that flows to the 8 ohm resistor is the total current. Okay? It is the total current of which we are required to calculate. It was 2,73. So it's 2 15.73. And what will be your answer? So you punch your calculator, and I think you're going to get 59.62 watts. So this can be an option as well. Or your second option can be power is equals to V squared divided by R. And what is your V? It's 21.84. Don't forget to do what? To square it. Divided by your resistance, which is 8. And then let's see what will be your answer. 21.84 squared divided by 8. And you can see that your answer is going to be 59.62 watts. I love this. I love this. Or you can calculate power by saying is equals to I squared R. And what is your current? It's 2.73 squared multiplied by 8 ohm resistor. And what will be your power? Let's look at it. 2.73 squared, then you say multiplied by 8, and your answer will be 59.62 watts. So any of these formula is accepted. So we need to be in a position as well to use, provided on what the scenario is giving us. Then let's look at the summary. We do say that let us associate ourselves with the exam guideline. It's very important. Let's associate ourselves with the exam guideline and provide definitions the way they appear from the exam guideline. If you can do that, we are winning. So let us make sure that we do that. The exam guideline should be our friend. And it tells us that the first thing that you look at is Ohm's law. And you must state Ohm's law in words that the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. At constant temperature. And you need to clearly evaluate the relationship between current, potential difference, and resistance. Because this is what circuits are about. They're about this triangle relationship between current, resistance, and potential difference. And then you must be in a position to calculate for power. And as well, power, it tells us about this relationship of current, potential difference, and resistance. So use this equation to solve problems the way it appears from the data sheet and substitute correctly. This is how we win physics. Paper 1, write down the correct formula. Substitute correctly. You get maximum marks. So thank you so much. Let us continue to sanitize. Let us continue to wear our mask properly. Let us continue to maintain social distance. See you next time. I thank you. I thank you. I thank you.